Okay, we are moving into solving for quadratics. We've done some graphing. We've done forms of quadratics as far as vertex form, intercept form, and standard form, and how to go from one to the other. We've done a little bit of factoring, and now we're going to find the solutions of a quadratic function by factoring and by finding square roots. So we've done some factoring. We're going to practice a little bit more. And so go ahead and take this note down. When given a quadratic in standard form or vertex form, you can either factor or use the square root method to find the solutions using the zero product property. And the zero product property just basically says, if you have factors of something, if I multiply either of those factors by 0, then my answer is going to be 0. Why 0? Well, we know that the zeros of the function, when y equals 0, it's where it crosses that x equals line, right? So it's that x-axis, x-intercept. So using the zero product property tells us that we're going to find the solutions of our quadratic function or equation. So it kind of tells you here, any number times 0 equals 0. You learned that a long time ago, right? So here we're just adding it to algebra. X times x plus 2 equals 0. Those are factors, so you set each factor equal to 0. X equals 0 and x plus 2 equals 0, and then solve. So here are our steps for factoring using the zero product property. Pretty simple. Factor first, and then set the factors equal to 0, and then solve for each factor. So let's try an example together. My pencil out here. Okay, so our first example is 3x squared plus 11x minus 4 equals 0. So this tells me I am looking for where my function crosses the x-axis, right? I'm looking for the zeros of the quadratic equation. So let's factor first. So I'm going to multiply my a and c value. That's negative 12. So I need two numbers that multiply to get negative 12 and add to get 11. Seems like it would be 12 and negative 1. Split our middle term. So we have 3x squared plus 12x minus 1x minus 4, keeping that 0 on the end. Group the first two, group the last two. What can we factor out of the first two? A 3x. So I have an x plus 4 left. What can I factor out of the last two? Not really anything, except there's a negative in front. So I'm going to take out this negative 1. So I have an x plus 4. It switches the signs. So my factored form is 3x minus 1 and x plus 4. So this was our step 1, right? This is the one, that's the factoring. Now my step 2 is to set each factor equal to 0. So we have 3x minus 1 equals 0 and x plus 4 equals 0. I don't really need the parentheses, but I put them there anyway for some reason. All right, my last step is to solve each equation here. I'm going to add 1 over here. 3x equals 1, divide by 3, and x equals 1/3. So that's one of my zeros. And on this one, I'm going to subtract 4. So x equals negative 4. So I have two x-intercepts, right? My x-intercepts are 1/3 0, because they're points, right? And negative 4, 0. So that's how we solve algebraically. Let's try another one. Let me get my examples over here. If I can, here we go. All right, let's try this one. This one's a little bit different. Yeah, let's try this one. We have 3x squared plus 36x plus 49 equals 8x. All right, so we have an issue, a little bit different. See, this one is equal to 0. In this one, or this example, it's not. We have to make sure that it equals 0 before we do any of this stuff. So we're going to move our 8x over first. because I can't use my zero product property if it doesn't equal 0, right? So we need to make sure that it equals 0 first. 36 minus 8 is 20, oh my goodness, 28. Equals 49 equals 0. So we're going to multiply our A and our C. Can I factor anything out? Oh, I can't. All right, so 3 times 49, 3 and 4 is, that's 120 and 27 is 147. 147, really? I'm going to check my math on that one. Okay, so 147, we want two numbers that multiply to get 147 and add to get 28. Ugh. Let's think about this. What multiplies to get 147? Maybe 3 in some number? By 3. Okay, 3 and 49. Hey, okay, this might turn out okay. And 7 and 7. So when I can't think of factors, I break my number into prime factorization, and then it helps me figure out what numbers might be it. So I have 3 and 7 is 21, plus 7 is 28. Wow, that just works out perfectly, doesn't it? So 21 and 7. All right, so we'll split our middle term. We have 3x squared plus 21x plus 7x plus 49. This is going to turn out pretty nice after all. All equals 0. Take our first two, we can factor out of 3x. So we have x plus 7. We can take out a 7 here. So we have x plus 7 equals 0. So we have 3x plus 7 and x plus 7 equals 0. Now that was our factoring part. Now we're going to set them equal to to 0 like we did up in the last part. 3x plus 7 equals 0 and x plus 7 equals 0. Let's see where our intercepts are. Put this up so you can see it a little bit better. 3x equals -7. Divide by 3. X equals -7/3. And subtract 7 on this side, and we have x equals -7. So our x-intercepts are -7/3, 0, and -7, 0. Now, because I'm curious, I want to make sure that we got this right. So you can do one of two things. You can, here's my Desmos graphing. You can put this in and this in and see where they intersect, right? Or I can put this in and see where the zeros are. I'm going to do it both ways. Let's see. Let's do 3x squared plus 28x plus 49. All right, my zeros are at -7, 0 and -2.330, which is the same as 7/3, -7/3. That's good. Let's try it the other way, just so you can see what that looks like. 3x squared plus 36x plus 49. So that's one of my equations. Now, there we go. And on the other side, see, I have an 8x. So that's another equation. So I have 8x here. Now, the goal for this is to see where these cross. I have it at -7 and where is this? -2.33. So that's pretty cool, right? So you can either, if it's set up like this to check your work, you can set this up in your graph, or this one, sorry, this one up in your graph and see where the zeros are, or you can set up two different functions. Kind of cool to see that. All right, so those were our two examples for solving by factoring. And here's solving using the square root method with steps. If you'll copy those down, please go ahead and pause and copy. When a binomial is squared, or it's in a vertex form, which is x minus h squared plus k, or if there's no b value, then you can solve using the square root method. So here's our steps. Isolate the square, whether a variable or a binomial. Take the square root, and we're going to look at both both of those examples. Take the square root of both sides. Don't forget that when you find a square root, there's a positive and a negative solution, okay? So when I take the square root of 4, what number squared gets me 4? So let's think about this. Show you this down here. So if I do square root of 4, what two numbers could get 4 if I square them? Well, I could square a -2 and get 4, or I could square 2 and get 4. So the square root of 4 is actually a positive or a -2. That's where you get that little sign there. So let's do a couple of examples here. Here's our example. This is example number 3. We have n squared minus 5 equals -4. So notice that we don't have a b value. We only have an a value, which means it's the number, it's the squared variable. We don't have just a regular n, so we can't really factor here. But what we can do is solve using the square root. So we're going to do step 1, which is isolate the square. So I want n squared on one side and I want everything else on the other. So I'm going to add a 5 to the other side. So I have n squared equals 1. So that was step 1. The next one is take the square root of both sides. So I'm going to take the square root of n squared, take the square root of 1. Now, the square root of n squared is n. The square root of 1, remember, is positive or -1. So our answer here for our x-intercepts is 1, 0 and -1, 0. And I'll show you what this looks like. So if we put this over here, we would have a -1. So it would be x squared minus 1. So notice, see there, our 2 zeros are at -1 and 1, because we had to get it equal to 0. We could set it up like this. We could do x squared minus 5, but we'd have to create another equation here that would be y equals -4. And then we would still look for those intersection points. Pretty cool how those graphs work. All right, next example. We have a different situation. This is example number 4. We have 2x minus 1 squared equals 9. So notice in this case that we have a binomial squared. Other option is always to FOIL it out and then factor it and see how it goes. Set it equal to 0 and see how it goes. This is just an easier option. All right, so it says isolate the binomial. It's already isolated, it's on one side. Now we're going to take the square root of both sides. So remember, when you take the square root, it's a positive or negative, right? So we're going to have to set up 2 separate equations. We have a 2x minus 1 equals +3 and a 2x minus 1 equals -3. All right, so let's go ahead and solve for these. 2x equals 4, divide by 2, and x equals 2. Add 1, 2x equals -2, divide by 2, and x equals -1. All right, so my x-intercepts are 2, 0, and -1, 0. Now let's see if we are correct here. So 2 different ways that we can do this, right? I'll close my graph out. 2 different ways that we can do this. We can put the 9 on the other side. So we have something that looks like vertex form, 2x minus 1 squared minus 9, right? So look at that. My intercepts are 2 and -1. That was what my answer was. Or we can set this up on one as a function, 2x minus 1 squared, and then we can say y equals 9 on the other one. There's my equal 9. There we go. So y equals 9 is up here. So my intersection point, -1 and 2. All right. So before you come to class, I have 4 examples for you before you try it. So here are your you try it examples. 1, 2, 3, 4. Go ahead and try these, copy them down, bring your solutions to class, and we will work on them together.